Okay, students, we're going to go over proof problems from old DCAS problems here. The figure shows quadrilateral RSUV. Notice it says quadrilateral. It didn't tell me parallelogram this time. But it says that RV is parallel to SU. Notice they didn't put the parallel symbols on there. So you need to look for that and put it on yourself if it's not already marked. And congruent segments as marked. Now, if you remember, this is the fifth sufficient condition to prove that this is a parallelogram. Okay? But that's not what we're trying to prove here. We're trying to prove that RU, segment RU, bisects segment SV. So we need to prove that those are congruent segments. Now, whenever you're trying to prove something that's got a vocab word in it, it's going to be definition of bisector as your justification or reason for that final step. And so if we look down here, notice it says definition of bisector. Whenever there's a vocab word involved in what you're trying to prove, it's always definition of that vocab word. Just know that in your final step. Okay, we have that given. Okay, angle KSU, oops, let's move this up. KSU right here is congruent to KVR. And we should know that from parallel lines cut by a transversal AIA, alternate interior angles theorem. Okay, that's the most popular one, as I've told you. SUK is congruent to, it's going to be this one right here, by the exact same thing. We have parallel lines cut by a transversal, therefore alternate interior angles are equal. AIA theorem. Remember, they're going to write the whole thing out. Now we can say triangle SUK. That triangle is now congruent to that triangle. We should be able to see it, ASA. Right there. Angle, the original sides given to us. Angle, side, angle. So we'll fill that in. Now these are going to be drop-down choices. And then remember, what do we use after proving triangles congruent? Any other corresponding parts are congruent by CPCTC. Okay, so now we have SK is congruent to VK. SK is congruent to VK, which would make them bisectors. Okay. And we're trying to prove that RU, segment RU bisects SV. So in order to prove it bisects it, we have to prove that these two are congruent. And so we just showed that they're congruent through CPCTC in that last step. Okay, so there's that proof. Oops, didn't go to the next page. So here's all the steps. So there's your alternate interior angles for that one we had. There's your alternate interior angles again for the next one. Part C, step 4, it was congruent by ASA, angle, side, angle. Part D, we had CPCTC. Okay, corresponding sides of congruent triangles. These are not similar, these were congruent. So he wipes out similar. Corresponding sides of congruent triangles are congruent. Or corresponding angles. We weren't dealing with angles in that case, it was sides. Now it would have been better to use, would have been CPCTC. Is technically a better answer. I've never seen this answer put down before, ever. Corresponding sides of congruent triangles are congruent. It should be CPCTC. Okay, so here we're given length AB. Remember, there's nothing above it. Length AB is congruent to CB. D is the midpoint. Remember, there's a vocab word. So if it's a midpoint, we're going to be able to say, into your proof, we're going to be able to say that by definition midpoint, that AD is congruent to CD, definition midpoint. Enter your proof in space provided. So 1 is the given. Okay, I'm just going to draw that right there. Reason given. Okay, next I have that vocab word, so I can now say segment AD is congruent to segment CD, definition of midpoint. Okay, and of course we have the free point we get ourselves. BD is congruent to BD. Reflexive property. Of congruence. Okay, so now we can say, now just so you know, they might, so they want to talk about lengths here, you can say segment AD is congruent to segment, let's make it as segments as opposed to just the length, CB. You can say equal lengths are congruent. Okay, and so now you have the segment being congruent, because that's technically what they look for. Now I'd be able to say that those three angle or triangle BAD and BCD, triangle BAD is congruent to triangle BCD. If you know that by SSS. Okay. Then I should be able to say, so you're trying to prove that those segments are perpendicular. So remember, that's right there. So that you know in the final step, it's going to be definition of perpendicular. Okay. So we need to show that they're 90 degrees. So therefore, now we got to say angle BDA and BDC are congruent. Angle BDA is congruent to angle BDC, CPCTC. Now I'd say measure of angle BDA is congruent to the measure of angle BDC, definition of congruence. Okay. Now we show the measures are equal. Now we need to state that they form a linear pair. Okay, because then you'll have 180 divided by 2 is 90. So angle BDA and BDC, and angle BDA and angle BDC are supplementary. Okay. Actually, we're not going to say supplementary. We're going to say linear pair. Or linear pair. Okay. Definition of linear pair. Okay. Now we can go ahead and say measure of BDA plus measure of BDC equals 180. Okay. That's also a definition of linear pair. Okay. And since we already have proven that the two angles are equal, okay, so now we can say the measure of angle BDA and measure of angle BDC equals 90 degrees. Okay. And now you can talk about from let's say definition of equal measures. Okay, because we up here in 7 we proved that they were equal. Okay, and then the last step would be able to say, since now I've shown that they're 90, I can now say that what I'm trying to prove, segment AC is congruent to BD. I mean, it's perpendicular, not congruent, to BD, and that's by definition of perpendicular. Okay. So that's a lot in there. Now they might let you get away with skipping some of these steps. Okay, it'd be a partial. It just depends on how strict they want to be. Okay. All right, next. Given B is the midpoint of AC and D is the midpoint of CE. Okay, prove that. We're trying to prove that that's parallel to that. Remember, that's the mid-segment theorem. Mid-segment theorem says if I have mid-segments, which these are by definition, BD's mid-segment, then the lines are going to be parallel. Now, so obviously the step one's given. Okay. BC is half of AC. We have that. CD is half of CE, midpoint theorem. Okay, because we have, that's like saying the definition of midpoint. That's the same thing as saying definition of midpoint. Okay, they're calling midpoint theorem here, but if you wrote definition of midpoint, that would also work. Okay, so remember I told you anytime there's a vocab word in the given, you're going to use it, and there you see it right there. BC over AC equals a half, and so does CD over CE is 1/2. Division property of equality. So what they did was they divided both sides here by AC. Okay, whatever you do to one side, you do the other side, so that cancels out, and that's why you have the 1/2. And they did the same thing over here. They divided both sides by CE. Okay, that's division property of equality. Now you have BC, so now they just substituted this in here. Now I told you it may be substitution or transitive property. Notice they use transitive property. Either one would work. You could say substitution or transitive property. Remember I told you if they only have one or the other to choose from the drop down, you're going to choose whichever one they have there, either transitive property or substitution property. Okay, so now we have this. We have angle C is congruent to self-reflexive property. Okay. Notice, as I said here, if corresponding angles are congruent, then the lines are parallel. That's the converse of the corresponding angles postulate. So that means they've shown that corresponding angles This is not true. That's what we're trying to prove. That corresponding angles are congruent here. Okay. Let's see. What do we want to use? So first off, just so you know, they're not going to ever have both sides like this blank for you in the DCAS. It would be, I've only seen it, so this is probably a very old one. It's usually either one or the other. Okay, so in step 6 of the proof, the statement, they're trying to prove the triangles are similar. Okay, we can't prove that they're congruent. Okay, but we can prove they're similar. Okay, by SAS. So we have SAS. And this whole thing is going to be similar by SAS. So the two triangles. So the statement is ACE, the big one, is similar to BCD. That's what you're going to choose. Okay. And the reason is SAS similarity. Okay. Notice it's definitely HL similarity. It's not SSS similarity. Looks like this is an error. So notice how it says SS similarity AA. Those are two different things, and they're putting them in the same one. That makes they are. It should be SAS similarity. So I'm guessing this is supposed to be SAS similarity. Okay. We have this right here. In step 7 of the proof, the statement is, so if they're similar, then that means all corresponding angles have to be congruent. So that means this angle would have to be congruent to that one, and this one congruent to this one once you've shown similarity. Okay, so that's what you're checking for from here. Angle CAE, CAE is the bottom one, and that would go along with CBD. That's not it. AEC, AEC is this bottom one here. That would go along with CBD. Nope, it's not that one. CAE, that bottom one, is going to CBD. Yes, those two are congruent. So it's going to be that right there. It's going to be step 7. And the reason is corresponding angles of similar triangles are congruent. Right there. And then the last step is already there for us. Okay. So I don't know why they have similar. If they want to put SAS similarity, that's fine. But there's some error in how that, because it should have been SAS similarity right there. Okay, let's go to the next problem. Okay, so that's just given information we can see from the drawing. Given angle CBD is going to BFE. Okay, well, those are corresponding angles. If those are congruent, then we know those lines are parallel right now. Okay, we're trying to prove ABF. I'll change the color. We're trying to prove ABF. We're trying to prove that is equal to BFE. Well, first off, we know that this is going to be equal to this vertical angle theorem. and then it's going to be equal to this with transfer property or substitution. Okay. So, part A. Which two of the given reasons can be used to correctly complete the proof? CBD is congruent to ABF, vertical angle theorem. Okay, so that's going to be used there, vertical angle theorem. And for ABF, we have transfer property right there. Angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. Transfer property. Congruent should just say transfer property. Congruence of angles is transitive. I've never seen it written that way. That's just how this book apparently did it, but that's just transitive property. That's what you're looking for. Okay, remember I told you if it's not transitive property, you'd be looking for a substitution. Notice they don't have both those there. All right, B now. This one. Given CBD is congruent to BFE, same thing again. Prove that measure of BFE, this one plus DBF plus DBF, which would be this angle there, is supplementary. Okay. Well, we have the measured angle CBD plus DBF as would be, and that would be linear pair theorem. Just angles are not necessarily supplementary or congruent. Okay, but linear pair theorem right there. Okay, and then you have the measure of BFE to DBF equaling 180, and that'd be through substitution. Okay, this one has to be substitution, so since they took this angle and substituted into that one right there. Okay, so that's the 2 for that one. All right, now we have this here. Angle CBD. Okay, it looks like, okay, so this is the same thing again with just drop down menu choices. Okay, so that's the exact same problems again. All right, here we go right here. Okay, so we're given this quadrilateral is a parallelogram. Remember? So that means opposite sides are parallel, opposite sides are congruent, opposite angles congruent, consecutive angles are supplementary, and the diagonals bisect each other. All the characteristics and the definition. Or the definition of a parallelogram is opposite sides parallel. Okay, so of course right down here given. Now they said their opposite sides are parallel. Definition of parallelogram. Again, you see the word parallelogram, so you know you're going to use definition of it to make things equal. Angle PQS. So we have these are parallel, these are parallel. Angle PQS is going to RSQ. Okay, that's AIA, alternate interior angles. So therefore, the other one is QPR. It's going to this one, AIA also. Okay, so we have that one. So two parallel lines are intersected, alternate interior angles are congruent. AIA right there. Remember I told you they're going to write out the definition of AIA theorem. That's what AIA theorem says. So it's the most popular one. Okay, here it tells me opposite sides of the parallelogram are congruent. So now we want to put opposite sides congruent. Okay, so which statement is justified the reason in step 4? So PQ is congruent to RS. Yes, that's true. PQ is congruent to SP. Nope. PT to TR. Nope, not for opposite sides. And SQ to PR, and those are diagonals. Okay, so A is the answer for that one. For C, so PQ to RS. Let's put that on there. PQ to RS. Okay, now we can see we have these two triangles are congruent by ASA, angle side angle. Okay, so that's what it's asking. Angle side angle goes right there, and then you're done. You notice here's your CPCTC written all out. Okay, and definition of congruent line segments. That could also be CPCTC. Part D, another method of proving diagonals of a parallelogram bisect each other using coordinate grid. Okay, what can be shown about the diagonals of parallelogram PQRS to complete the proof? Now, PR and SQ have the same length. No, SPR is perpendicular bisector of SQ. Well, that'll make it bisect SQ, but it says can be shown that the diagonals, both of them. So that's only one pair right there. That would do it for one pair, but not for both. We want the diagonals. PR and SQ have the same midpoint. That's going to be showing that they bisect their midpoint. Means they're going to everything midpoint bisect. You're thinking midpoint formula. So you see that right there, the word midpoint. They're going to have the same midpoint. So that means that's congruent to that, and that's congruent to that. So they have the same midpoint. That's what you're looking for. Okay. All right. In the diagram, A, B, C, and D, E, F below. AB is congruent to DE. Angle A is congruent to angle D, and angle B is congruent to angle E. Okay, well, we already have the two triangles are congruent by ASA. It's already set up for us. Which method can be used to prove that they're ASA? Nice and easy right there. Given this, and C is the midpoint of BD, then remember we use midpoint formula to say that that is congruent to that in one of my steps. Actually, the first step. And it's not only the midpoint of BD, it's also the midpoint of AE. So I'm going to say that those two segments, I'm not going to write it out, but you just say AC is congruent to EC and DC is congruent to BC, definition of midpoint. And then I'd have vertical angle theorem. Angle ACB is congruent to DCE, vertical angle theorem. Now you have that the triangles are congruent by SAS. And then I would say that this angle is congruent to this angle by CPCTC. And then if I would be able to say this is congruent to this by converse of the AIA theorem. Okay, alternate interior. If alternate interior angles are congruent, which angles B and D are, then the lines are parallel. So it's the converse of the AIA theorem. Okay, that's how you would prove that. The diagonal AC is shown in the parallelogram ABCD. ABC. Oh, this is 17. I'm looking at it down here. This drawing. The diagonal AC is drawn in parallelogram ABCD. ABCD. The diagonal is drawn right there. And it's a parallelogram. So we know that this is parallel to this. This is parallel to this. Then we have AIA that we can use and reflection property to get the two triangles congruent. Which method cannot be used to prove triangle ABC is congruent to CDA? Okay. Well, first off, SSA is not one. So that cannot be used to prove. So you cannot use that to prove it. You'll be able to prove it through ASA, SAS, because I could show, remember, one of the characteristics of parallelograms, opposite sides are parallel. I mean, and congruent. The definition is parallel, but they're all opposite sides are both congruent as well. So I could then have that set up and have SSS because I have reflexor property with AC, and SAS because I have alternate interior angles. Okay, yeah, so SSA is your answer. There is no SSA one. There's a little SA, but not SSA. Okay, in the diagram of ABC below, AE and BD intersect at C, angle CAB is going to CED. And of course, we have this is going to this. Okay, which method can be used to show that ABC must be similar? Remember, that's all we have is AA similarity right there. We only have those two angles right there, the free point you get with vertical angle theorem. Given quadrilateral ABCD with AB. Okay, so I have quadrilateral. I'm just going to draw it sort of like a parallelogram. AB, CD. AB is congruent to CD. AD is congruent to BC. Well, now if we have opposite sides congruent, then we know it's a parallelogram. And diagonal BD drawn. Prove measure of angle BDC. This one right here is congruent to ABD. That one right there. Well, I would have, well, I could do it one of two ways. I could just show it's a parallelogram and then say that lines AB and DC are parallel by definition of parallelogram. Remember, I'd be saying that this is a parallelogram by one of the sufficient conditions of parallelogram. If both pairs of opposite sides are congruent, then it's quadrilateral is a parallelogram. It's one of your 5 sufficient conditions. Now, the other way is obviously I could go ahead and do reflexor property right here and prove those 2 triangles congruent, and then I'd be able to say those 2 angles are congruent by CPCTC. So 2 different ways right there. All right, number 7. AG, okay, GAE is congruent to LOD. Okay, they have that right there. AE is congruent to OD. Okay, to prove that AG and OLD are congruent by SAS. If it's going to be SAS, there's SA. The only other S there can be is that one right there for SAS. What other information is needed? You had this in one of our worksheets. To prove the triangle is congruent, we add the other, what's the needed piece? So you have to know what SAS looks like. And so we need that right there. AG is congruent to OL. Okay. All right. We should almost be done. Yeah. A few more. Okay. Given parallelogram, ABCD. ABCD, okay. BF is perpendicular, okay, and DE is perpendicular right there. Okay, prove BEDF is a rectangle. Okay. Well, the way you can prove that, I'd be able to say that this is congruent to this, parallel lines, definition of parallelogram. Okay. I'd be able to say these are both perpendicular. Okay. So I have 2 right angles, and that'd be using linear pairs or supplementary, since one is 90, the other has to be 90. You can write this out in a paragraph proof. By the way, you don't have to do a 2-column proof. You can just explain this in words. Okay, that's called a paragraph proof. So therefore, that has to be perpendicular by definition of linear pair. Okay, and same with that angle. Then I have this angle and this angle have to be that one has to be 90 degrees because again we have parallel lines cut by transversal, same side interior angles are supplementary, which makes angle FBE perpendicular, and this also, okay, the same way. And now we have 4 right angles, which is the definition. One of the definitions of a rectangle is when I have 4 right angles. And so now I can say that that's a rectangle by definition of rectangle. All right, Kelly's completing a proof based on the figure below. She was given an angle A is congruent to EDF. EDF, that right there. And has already proven segment AB, so I'm just going to call it like this, is congruent to DE, this one right here. Which pair of corresponding parts in triangle congruency method would not prove ABC is congruent to DEF? So if they give me this extra piece, AC is to DF, AC to DF. Now that'd be SAS. Is that what it says, SAS? Yes, it does. So we want not prove. That is a proof. Okay, so now I get rid of that one, that piece. Oops. This was right here. Get rid of that one of it. Okay, BC to EF. Okay, that is set up as an SSA, and there is no SSA. So this is our answer. That's not. Okay, that's an SSA setup. So there's our answer right there. So again, knowing your 5 ways of proving triangles congruent, SSS, SAS, AAS, ASA, and HL. You need to know what each one looks like. Okay, given RS and TV bisect each other at point X. So if they bisect each other, then that is equal to this. This is equal to this. And TR and SV are drawn. Well, then I can obviously go ahead and prove these two triangles congruent. I have vertical angle theorem there. Then I have the two triangles are congruent by SAS. Then I can say corresponding angles are congruent. That one corresponds to that one. And now I can say that those two lines segments are parallel because of the converse of AIA theorem, because those are alternate interior angles to these lines right here. And so if alternate interior angles are congruent, then we have that the two segments are parallel by converse of the AIA theorem. It's back when we we're doing our proofs right there. Okay. Now, just so you know, this is a very popular one. Dang it, I guess I can't. Let's change the view, see if I can see the question. Okay, so you're gonna let me move the whole thing at all? Let's see if I put this here. Put this here. Well, let me move it. So what they're trying to prove here, this is a very popular one. You better know it. Okay, again, on the DCAS, they have it filled out like this. You'd be filling in the blanks with drop-down menu choices, or they might just ask you to prove it in a paragraph proof yourself in a box. Okay, so then remember this. This is almost on every single DCAS, this proof itself. And it's probably going to be on your final and filling in a box. Okay, so draw a line BD parallel to AC. Oh, there it finally moved. An incomplete proof of the theorem of the sum of the interior angles of a triangle is 180 is shown. Okay. So they first drew in BD, segment BD or line BD, segment until you put the arrows on. Now it's line BD, parallel to AC. They drew that in there. I can't think of the name. Some have a particular name for the theorem. Just say drawing. Just say drawing. Okay. Now, remember this is parallel. We drew it parallel. So now I can put these parallels on here. Okay. So now what I'm going to say is the measure of angle 1 is congruent to the measure of angle 5. Okay. And the measure of angle 4 is congruent to the measure of angle 3 by AIA. Okay. That's what you're going to now say. Okay. Now, notice this, the measure of angle 2 plus the measure of angle 4 equals measuring angle ABD. That's true. The measuring angle 5 plus the measuring angle ABD equals 180. Angle addition postulate. Remember, they added these two angles together to get that single angle. Added these two angles together. Equals 180. Okay, I haven't seen a proof done this way before. On this one right here, there's a much simpler way. You can just say the measuring angle 5 plus 2 plus 4 adds to 180. Definition of straight angle. Okay, and then I would have after saying the 1 and 5 and 2 and 4, then I would use substitution to say 5 is going to 1, 4 is going to 3, and substitute that in there for that 180, which is what they end up doing down here. Okay, and notice they're using substitution. So you have 5 plus 2 plus 4 adds to 180. Substitution property. Okay, you could have, to me, you could have jumped right to this with straight angle property. Okay. I suppose I need to do this step 3. And now you have measure angle 1 plus 2 plus 3 as 180, because remember you already have that these are congruent, and you can use substitution property again. Okay, because now you're substituting in 1 for 5 and 3 for 4. So I think you could have skipped 3 and gone 1, 2, 4, and 4 would be straight angle. Definition of straight angle. Okay, so you could have gone 1, 2, 4, 5. Okay, know that because you're going to see it probably on the DCAS in your final. That's a very popular one. Okay, so here'd be your definition right there. They have it as a drop down right here. Through a point not on the line, there's exactly one line parallel to the given line. Okay, that's going to be your answer to justification for this right here. 2, which pairs of congruences or equalities should be used for statement 2? We already said which those are. So we're going to have 1 and 5. You're looking for 1 and 5. Okay. And you're looking for 4 and 3. Right here. Okay, that's what you're going to use for that one. And then select from the drop down to correctly compare the sentence, the reason for the statement in step 2. I don't know what it says right there. That's going to be, as we already said here, AIA is what you're looking for. That you pick from that drop down menu. Must complete for the appropriate step 5. Step 5 it's going to be substitution property. You're going to pick from right there. Okay, I think this is the last one. Yes. Okay. Shown BA is congruent to BC. Well, what do we have then? On a sausage triangle, very first thing you're, you're trying to prove A is congruent to C. The isosceles triangle theorem. That's what you're trying to prove is the isosceles triangle theorem. So obviously you write down what's given. Step 1. Okay. Okay. Using this. You'll never have this like this in the DCAS. They don't show these drop downs. Okay, it'll never be anything like this. I've never seen this on any of the DCAS, so this must have been a really old one. But see how they're using definition midpoint? That means they drew the median. Okay, they drew the median. So draw median from angle B. Okay. Draw median from angle B and call it D, intersection point D. Okay, and then that'd be definition of median. Okay, remember median goes from the vertex to the midpoint of the opposite side. So since this is the midpoint of the opposite side, now I can say AD is congruent to CD, segment CD, by definition of midpoint. Okay, because within the definition of median, you have the word midpoint in here. Okay, it goes from the vertex to the midpoint of the opposite side. So there's that vocab word right there. So that's why then I can use it right there. So then I have this. Okay, then I'm going to say BD is congruent to BD reflexive property. Right there. Congruent to BD reflexive property. That's our free point of congruence. No, this is equal. I'm saying equality here. I'm going to make it congruent of congruence. Okay, so now I have that. Now I'm going to say the two triangles are congruent. So triangle ABD is congruent to triangle CBD. Remember, we put it in corresponding order. And that's going to be by SSS. And lastly, what I'm trying to prove, you draw it just as it is, angle A is congruent to angle C. You don't switch anything up by CPCTC. Okay, and you'd have all those there to choose from in your drop downs. Okay, so that's going to be CPCTC. Okay, so there you go right there. That covers a bunch of proofs. 48 minutes.